Hey guys, in this video I want to go ahead and go over some more rate accumulation problems for the FRQ for this year's AP exam. This is from 2018, so the purpose is just to be able to understand what they're asking, get an idea of the pattern, the routine, and the type of questions you will be asked. Okay, so I almost guarantee that you'll get one question kind of like this where something's going in, something's going out, a real life scenario. So it says people enter a line from an escalator at a rate modeled by this function. Okay, where R of t is measured in people per second and t is measured in seconds. As people get on the escalator, they exit the line at a constant rate of 0.7 person per second. There are 20 people in line at t equals 20. All right, cool. So let's go ahead and start. Part A, remember, is the easiest part. That one's short and straight to the point. It says how many people enter the line for the escalator. How many? You see that right there? How many people enter the line? So they give us a rate. Well, whenever you integrate a rate, you get an amount. How many people? So this is the rate of people entering the escalator. So all we got to do is we can integrate from 0 to 300 of RT dt. Plug that in your calculator and you should get 270. Okay, so how many people enter the line? 270 people enter the line for the escalator during this time interval. And that's it. So when you're answering these questions, look at the question itself and just restate it. Use their exact words to answer your question. And that's it, guys. 270 people. Now make sure you give the answer in the units, okay? All right, part B. During the time interval between 0 and 300, there are always people in line for the escalator. How many people are in line at t equals 300? Well, when people are in line, you have to take into account everything that's going on. So we got to look at the total, okay? So remember what we said about the total. We start off with our initial, well, what's happening? How many people are in there? Plus what's going in minus what's going out, okay? So what's the total? The total amount, okay, well, what's the initial? There's 20 people that are waiting in line when we start. Okay, so 20 plus, what's the rate of going in? So the rate of going in is this guy right here. So we're going to take the integral from 0 to 300 of RT dt. Okay, and what else is happening? Well, it's exiting at 0.7 minus 0.7. Okay, people per second from 0 to 300. Okay, now I can go ahead and clean this up, but I just kind of wanted to give you the expression here. 20 plus, these are the same, so we're going to go from 0 to 300 of RT minus 0.7, close that off, dt. Okay, and that's pretty much it, guys. And then what you would go ahead and do is find your answer. Now I like to use A, okay. A of 300, the amount at 300, that's going to give you 80. 80 what? There's 80 people, okay. Okay. So the way, if you get confused, just go back to this one. Once you get your answer, okay, during the time interval, there are 80 people in line. Or you can just start here. There are 80 people in line at t equals 300. And that's it. But hopefully that makes sense because you have to incorporate everything that's going on. People are waiting, people are going in, and people are exiting. Okay, and that's it, guys. Let's go ahead and do part C. Let's go back here. All right, part C. For the time after 300, okay? That's important. Now this comes a part where, you know, A and B is pretty isolated, B is pretty isolated. Now C and D, chances are you're going to need to use information from A and B. So we'll see. It says, what is the first time that there are no people in line for the escalator? So take a picture and image what's going on. Okay, this is after 300. Okay, so at 300, there are 80 people left. When are there no people left? Well, people are still exiting at 0.7. So after 1 second, 0.7 left. After 2 seconds, 1.4 left. After 3 seconds, so on and so forth. Okay, so we're going to take these 80 people that are left, divide that by 0.7, and we're going to end up with 114 point, I think it's 286 seconds. Okay. So that's how long it takes for these 80 people to basically become no people. Okay. So that would be your answer. So you could actually write for t greater than 300, the first time, okay, that there are no people online is at 114.28 seconds after 300. Or if you want to write it, 300 plus 114.286 is 414.286 seconds. Okay, and you would say at 414.286 seconds is the first time there are no people in line for the escalator. And that's it, guys. Okay. But being able to understand what's going on from the first previous parts, it will really, really help you guys. All right, part D. For the time interval between 0 and 300, at what time t is the number of people in line A minimum? You see that? It's a minimum. Okay, what does that mean? Think back to maximum, minimum. How do we find the maximum? How do we find the minimum? Well, remember, we have our function. We take the derivative, set it equal to 0. From that, we get our critical points. From that, we use our number line, remember, to see when it's increasing, decreasing, and we're able to find our max and our min. Okay, well, what's our function? Well, what is our function? You have to incorporate everything. Okay, so what's our function? We're going to write a generic a of t, okay, and that's going to be something we already figured out over here, okay? The initial, 20, plus the integral. Now, I'm not going to go from 0 to 300. I'm just going to go from 0 to t because it's our general function. And then instead of r of t, I'm going to just do another variable. I'll just do x. r of x minus 0.7, okay, and then dx. That is my general function. My initial, what I start, what goes in, and what's the rate of going out. Okay, so that's my function. What do I got to do? Take the derivative, set it equal to 0. Okay, a prime of x, if I take the derivative of 20 is 0. The derivative of the integral, remember, is fundamental theorem. They simplify each other out. All you got to do is replace the t, replace the x with a t. So this becomes r of t, okay, minus, okay. This guy, you just leave it, same thing, okay? Because remember, the derivative and the integral, they undo each other, okay? If I take the antiderivative of 0.7, that means it's going to become 0.7t. If I take the derivative of 0.7t, it becomes 0.7, okay? And that's it, okay? So be careful with that. Remember, the derivative and the antiderivative, the integral, they cancel each other out. So you're just left with r of t, replace it, minus, and then the 0.7. Okay, so now we have this. What are we going to do? Set it equal to 0. Okay, so that means 0 is equal to r of t minus 0.7. Solve it. So that means we're going to try, let's see, r of t equals 0.7. That's what we want to find out. Okay, so you're going to take your calculator and you're going to set it equal to 0.7, or you're going to graph it and you're going to graph y equals 0.7 and see where they intersect. And when you do that, you're going to see that they intersect at 2 points, okay? You're going to be, the first one is 33.01313. I'll just truncate it. And the second time interval would be 166.575. Okay? So, now, look at the question carefully. It says, at what time is the number of people in the line minimum? Is there a minimum here? Is there a minimum there? But then look at carefully. To the nearest whole number, find the number of people in line at this time. So they actually want me to find the number of people. See, this is not my minimum. This is the time at which it might give me the minimum. So remember, this is one part where you have to figure out the beginning, the middle, and the end. What's the beginning? 0, the amount at 0. What's the middle? Well, it's these 2 points, so you need the amount at 33.013. You need the amount at 166.575. And you need the amount at the end point, at the very, very end, which is what? 300. So we know the beginning, we know the amount. At the beginning, there's 20, and at the end, there is 300. I'm sorry, there's 80. There's 80. Okay. So now I take my calculator, plug this in to what? Well, you're gonna plug it into here. Okay. You can just plug it into here as well, because it's from 0 to 300, right here, just like we did with the other ones right here. 33.013. Plug it in there, and let the calculator do the work for you. Okay. And then same thing, plug it in. And the only problem is, this function is a little bit weird, but if you want, you can go ahead and just plug the whole thing in there. Just be careful, and when you get it out, you should get 3.803, and the other one is 158.070. And you got to figure out, okay, does this make reasonable sense? And it seems like it does. If you get something like 575,000, you know something's off. So where is the minimum? Okay, well, it's right here. The number of people in line is a minimum at 33.013. Okay, and there's about 4 people, okay, in line. Okay, so notice how we did that. Okay, so it's very important to be able to figure out the general equation, take the derivative, set it equal to 0, and then go from there. Okay, you just have to be careful with your calculator process. So that was 2018. Let's go take a look at 2019, and I want to show you guys, see if you guys can see the pattern. Okay. And this one, you have a fish entering a lake, modeled by the function, this guy. This is entering. And then fish leave the lake at a rate modeled by the function, this one. Okay. Both E of t and L of t are measured in fish per hour. T is measured in hours since midnight. Okay, good. That's all they give us. Letter A, how many fish enter the lake over the 5-hour period? You see that? How many fish? You're going to integrate a rate. When you integrate a rate, you get an amount of what? The fish that enter. Which one's entering? This one right here. E of t. Boom. E of t dt from 0 to 5. Okay. And there it is. Plug that into your calculator, and you get your answer, guys. And let me check what that one is. For that one, you should end up with 153.45, and that's 690. Now, look at it carefully. It says, give your answer to the nearest what? Whole number. So, that's not a whole number. So, you would end up saying it's 153 fish, okay? And if you want to be specific, you said 153 fish enter the lake over the 5-hour period from midnight to 5. Okay, depends how much you want to write. All right, and that's it, guys. That's it. Part B. Part B, what is the average number of fish? Oh, keyword right there, average number of fish that leave the lake per hour. That leave, notice that, so we're going to be using this guy over the 5-hour period. So average number, or the average value, hopefully you should have this. If you don't have it, write it down. Memorize this one. You're going to be using this one, I guarantee you. This gives you the average value of a function. So 1 over b minus a. Okay. Now from where to where? Well, simple. From, actually I should do it over here. From 0 to 5. Okay, the first 5 hours. Okay, so that means we're going to get 1 over 5 minus 0. And then the function that's leaving is LT dt, okay? And that's going to give me 6.059038, okay? So what is that? That's the average number of fish that are leaving. You say you don't know how to answer it, okay. The average number of fish that leave the lake per hour over the 5-year period is, boom, there it is, 6.05093, okay? And you would just probably truncate it to 6.059, all right? That's it, per hour, okay? So if you get confused, like, well, how do I write it? How do I do it? What? Just right here. The average number of fish that leave the lake per hour over the 5 hour, and that's it. And you just answer this, boom, okay? Part C. It says at time t between 0 and 8 is the greatest number of fish. At what time t, okay, between 0 and 8 is the greatest number. You see that again? Greatest number of fish in the lake. Again, another maximum minimum problem. Okay, max min. So what I like to do is I like to write the general equation because I'm gonna need it either way. Okay, so you got to incorporate everything. So we need, same thing. We need to take our function, set derivative, set it equal to 0 to get our critical points, and then we use our number line. Okay, cool. All right, what's our function? Okay, so a of t, because a is the amount of what we're talking about with respect to time. Okay, are there any initial condition? Is there anything already in here? No, they don't. There's nothing. Okay, that makes it easier for me. So now what's going in? Boom. E of t. Okay. E of t. That's my rate. From where to where? I'm going to go from 0 to t because this is just my general function. Okay. dt. I'll just do 2 of them. So that's what's going in minus what's going out. What's going out? Same thing from 0 to t of lt dt. Okay. I'm just going to go ahead and put this together. A of t equals the integral from 0 to t of E of t minus L of t dt. And actually, I keep forgetting. Let's use another variable because we're going to be doing the integrating with respect to t. Okay? And okay. You can use x. I always like x. Okay, because when you do the antiderivative, right, you're going to be replacing it here. So we're replacing it. We're taking the derivative with respect to time. So that's why I had to use a different variable. So this is my general function of what's going on. So now I got to take my derivative, a prime of t, set that equal to 0. So if I take the derivative of this integral, well, they simplify each other. I'm just replacing it here. And you guys, I think, all know how to do that at this point. Minus L of t. That's it. Okay. Now, this is one way of looking at it. Some of you maybe have already seen, hey, they already gave me E of t and L of t. And you're right. Okay. You're right. Okay. So, where is the greatest number? So, we take the derivative, set it equal to 0. Okay. So, we have E of t minus L of t. And so, we actually want to find out where E of t is equal to L of t. And what you can do is you can just graph both functions and see where they intersect. Okay, so you're going to get a critical point at 6.203. I'll just write the whole thing, 56. All right, there it is. So now what do? Now look at it carefully. When is it the greatest number? See, what are they asking for? The number. That's not a number of fish. That's just a time. So now what do I have to do? I have to figure out the beginning, in the middle, my critical point, 3, 5, 6. And then I have to figure out the end, okay, at 8 hours. Okay, in the beginning, we already know how many fish there are, none. In the middle, you're gonna take this guy, okay, and you're just gonna go ahead and plug them in here, okay, for your rates, okay, and use these two right here. All right, just plug it in, and then you should get 135.5 0.01492. And same thing with your 8. Okay, plug it in. All right, and remember this is time. And then so when you plug in the 8, you should get 80.91998. Okay, so you take your general function here, a of 0, okay, plug it in here, you get 0. 6.20356, plug it in here. Now this is your function, okay? This is your function. So remember, you're gonna be using this guy and this guy, but let your calculator do the work. And then same thing, a of 8, okay? A of 8 right here, boom, plug it in here, use your calculator. So where is the greatest number of fish? Right here, okay? And then how do you answer that? Well, the greatest number of fish in the lake is at 6.203, and they have 135 fish. Okay. All right, and last part D, and let's go ahead and do that one. I don't think I have room, but I'll just do my best. Is the rate of change in the number of fish in the lake increasing or decreasing? Now part D, yeah, it is the toughest question. You really have to think about it carefully, but look at this carefully here. Is the rate of change in the number of fish, okay, is this guy right here. This is the rate of change entering, rate of change leaving. Is the rate of change in the number of fish increasing or decreasing? When you see is it increasing, is it decreasing, you're already talking about a rate. So they actually want you to find the rate of the rate, if that makes sense. So what we have to figure out is at t equals 5, are more fish entering than are leaving, or are more fish leaving than are entering? So we have to find E prime of 5, and we have to find L prime of 5. Okay? And E prime of 5, you're going to use your calculator, is negative 6.80174, and then L prime of 5 is 3.92102. So at t equals 5, this many fish are entering. You see it's decreasing. At L prime of 5, this is what's going on. Okay? Now what's happening? The fish are entering. Okay, so let me do it carefully here. Negative 6.80174 minus, well, why minus? Because the fish are leaving. 3.92102. And then you should get negative 10.7222, I'm sorry, negative 7.7228. And that is negative. What's happening? Okay. See how it's negative? That means it is decreasing. So at t equals 5, the number of fish in the lake is decreasing, right? Because this is negative. Okay, you show E prime of 5 is this guy, L prime of 5 is this guy, and then you would E prime of 5, actually I would write E prime of 5 minus L prime of 5, and then it's less than 0. And that's how you have to do, and then they can see this. Because what the graders, what they want to see, when they grade this, they want to see, okay, where are the points? Can I see? Whether it's a picture, a diagram. If they can't find it, then you know what, forget it. It's over. If you see a messy paper, it's pretty much, you're making their life a lot more difficult. Remember, these are human beings. If it's nice, neat, and organized, it'll be a lot easier for them to find the solutions. Okay, I know what you're saying, but still, okay, you just make their lives a lot easier. All right, guys, so hopefully that helps you out, and I'll keep doing more of these problems. Let me know, and then see what other problems you're having trouble with, and we'll work on it. Thank you so much.